Ganesh Ramakrishnan is our alumnus in every way, BTech and PhD from IIT Bombay, and has been with us for over 20 years, about 20 years maybe, something like 15 years. Okay, that's actually a short time for the amount of work he has done here. So, by the way, I forgot to also mention that Supratik is also Bajaj Chair Professor. Currently, Ganesh is Bank of Baroda Digital Entrepreneurship Chair Professor. Let me just have to zoom in a little to read all the awards. So, some of the interesting ones, Ganesh actually does fundamental research in machine learning, methods, subset selection and features. He'll talk about those a little better. But he has a massive interest in applications and societal impact of his work also. In fact, I'm collaborating with him in some educational applications. It's really great to see him working with great equal enthusiasm on that. He has already gotten a Patwardhan Award from the Institute earlier in 2020. Recently, he got a National Award for E-Governance, some gold medal. He's also been recently named, along with Pushpak, in most influential global leaders, top 100 in AI/ML. Even with all this, there are some of them who even win teaching awards. So he's won the Departmental Teaching Award also in 2023. Without further ado about this particular work, Udaan project I have heard a lot about. He refers to a lot of that work when we are working together for shared methods for solving those problems. So I look forward personally to hear more about this talk, and you can add more. Thanks.
Thanks, Mr. Varsha, for the generous introduction. I'm grateful to the Institute for recognizing this work. As you can see in the keyword here, there is data efficient, scalable, end-to-end document machine translation. So hopefully we'll do justice to some of these keywords as we progress. But two specifically inputs here, which is one is the Udaan repository itself, which is open source. And there's another very important component called SPEAR, which stands for semi-supervised data programming, both of which actually form part of this large ecosystem. And both of them have got a lot of fork branches and also star ratings. And this is not possible without a lot of foot soldiers in this entire effort. Specifically, Ayush Maheshwari, who was my PhD student who just graduated, he's with NVIDIA as of now. But there are many others, and there's some follow-up work which also resulted in very useful collaboration. So too many to name right now, but they're all listed here. Let's start with the problem statement. If I have a document to be rendered and translated in a language of desired choice, what would I do? This is how our interface looks like. You'd pick a source language, a target language. You would also specify if you want to do what we call optical character recognition. But very importantly, you also want to specify what the domain of that document is. The translation rendered in a particular domain will become useless if the translations have inconsistent usage of the vocabulary in that target language, and if especially you'll need a lot of heavy lifting to be done to be able to make the model attenuated to that target domain. Can we use zero-shot ideas? Zero-shot would mean I just can inject dictionaries, as you can see on the left-hand side, and get translation that is as per the dictionaries without breaking the fluency, which is very important. I want translation which is faithful to the dictionaries. Now, what are the elements of that? Here's an sample document being ingested. As you can see, there are very complex layout elements in the document. Very often the document is not even machine readable. Right? So this is an input document. What could you do with that? Well, this is how our editor looks like, where you can get the source document, get translation with dictionary constraints. So you can see the word Sarani is translated, the table is translated as Sarani. And because we maintain this provenance, provenance is a keyword all through, it's been used extensively in databases for explainability. But here you have the provenance in the form of both the translation alignment, which is Sarani as table, Yojak as adder, and so on, and provenance also in the form of the HOCR, or the alignment between the output boxes, bounding boxes in the image, right? And even if you had a machine readable document, this is not easy to get. And specifically for the translation, I should be able to ingest a dictionary. For example, this rule has to be implemented. Rule could mean Shasan, Prabhuta, Adhikar, Niyam, right? The model should be able to pick up the right translation without jeopardizing the fluency of the translation. Is niyam ko lagu kiya jana chahiye? And if you look at some other baseline, is adhikar ko lagu kiya jana chahiye, which is actually quite off, right? We had extensive studies demonstrating 6 to 10 speed up factor over conventional methods, including Google-based methods like Google Translation Workbench. And happy that a lot of publications resulted, large number of them with Ayush Maheshwari here, which I mentioned earlier. And this, once we developed confidence, we had the former principal scientific advisor launch this on Hindi Divas, and this has been extensively used by AICTE, state, ministries of education, and so on, Bank of Baroda, etc. Now, what are the ingredients? I'm going to do a little bit deep dive. So the first, which I refer to as dictionary constrained translation, and you can see the output here, right? You have a very complex sentence. A successful bidder shall execute a service level agreement and non-disclosure agreement and blah, blah, blah. And now you can see even in such complex settings, it's not just dictionaries based on single terms, but very complex terminology, seva star karar or gair prakritikaran karar, right? If you didn't have these dictionary constraints, you can see the translations all over the place. Most often words just get transliterated. And I have nothing against transliteration, which is rendering words in the source language words in the target language script. But we need some control. Without explainability, AI cannot be as effectively used, right? I won't go into the detailed architecture of this approach, but this approach is, while it's published, it's largely about the use of zero-shot methods, right, and using prompts in the entire process of machine translation. The second ingredient to make this happen, this end-to-end document machine translation, is high-fidelity document layout analysis. Now, I've shown examples beyond just the textbook example, where you could also have receipts which need to be rendered and translated. Now, what is interesting is that many ideas from conventional signal processing can be actually put to good use, right? Everything is not about large language models, and thankfully there is very little large language model in this current work. What we are able to do is using a combination of key value pairs and bounding box specifications, write something called labeling functions. Labeling functions are basically, I'm happy that Supratik and Akshay presented their work on, right, largely to do with functional synthesis. Right? Labeling functions take a complex object as input. You could write them in Python and basically produce some output. The ability of our data programming approach, which I talk about a little later, is bring together multiple labeling functions with either no or very little labeled data, using graphical model, learn parameters associated with these labeling functions, and produce output that is robust. Right? So this is what also makes it possible in our tool to bring in semi-automatic post-editing. So imagine a person starts editing the text, right, and figures out issues in the text, the translated text. Can the model learn on its own? And you can see there's a human in the loop learning. It could be, the edits could be as simple as replacing signal with sanket or analog with anurup, or it could be very contextually sensitive replacements. Now these are also programs. Every edit in the tool is a program, right? Now this is important because in this process, entire process, we are not just creating the translation, but we are also creating parallel corpus. Through the provenance, we are actually creating very fine-grained data, right? So all this is data, and this data is in the form of labeling functions. So that's the third ingredient. I'm going to delve a little bit more into this entire important field of data programming, and I think it's going to become even more important. People ask me, are the advances in large language models going to threaten domain-specific knowledge, I think, is just going to help refine domain-specific knowledge. Quack work in domains is going to stop, right? Because you need to be good at your domains to be able to articulate good labeling functions or good programs. So we brought out this open source platform called Spear, which I mentioned in the opening slide, where you could actually write multiple programs, all right? And what we offer is a joint approach, where you can learn parameters of these labeling functions in conjunction with labeled and unlabeled data and come up with joint inferences. That's called joint approach. This was somewhat inspired by a big initiative at Stanford called Snorkel, where they have a cascaded approach, where you use these labeling functions, learn parameters, label data, and then throw away the labeling functions. So in an opposite spirit, we consider these labeling functions as quite sacrosanct. While they're not binding, we don't want them to be just used and thrown away, right? So they actually are part of the entire ecosystem in the joint approach. So that's where we have a bunch of publications. Now, a little bit more through examples. So imagine an exemplar, right? Name a canine cartoon character other than Huckleberry Hound to have a voice by DOS buffer, right? Now this entire example could itself be a labeling function, or you could actually generalize this to a regular expression which could cater to the, which could serve the purpose of a labeling function. You could also have heuristics which could be labeling functions. As an example, a dictionary of certain prefixes. Or the example I gave earlier, you could have a combination of key value pairs and bounding boxes as labeling functions. So it's a very large spectrum. More examples, right? Let's say I'm trying to classify text as spam on YouTube, right? So if the description is if there's an HTTP or HTTPS in the comment text, then return +1. Otherwise abstain, right? So these labeling functions can not only give labels +1, -1, but could also abstain. So each labeling function is associated with some class. That's the premise here. Now, the data setting is that we could have a labeled set with some clean labels, but this is optional, right? You could have a large set of unlabeled data, and this unlabeled data could be subject to these labeling functions. LF stands for labeling function. And what you get as output are so-called noisy labels. As I said, these labeling function outputs are nowhere binding, right? You could use the the labeled set in conjunction with this unlabeled set, or use only the unlabeled set, or the other extreme case, which is very conventional, is use only the labeled set. All these combinations exist, right? So now what we're dealing with is number of instances, which include labeled and unlabeled examples, the number of labeling functions, and use this to induce labels on those instances, right? So broadly speaking, it's a consensus finding problem. And as I said, you may use a small amount of labeled data. In fact, we have some follow-up work where we also induce these labeling function. But I don't talk about that. So the complete model has the feature model, the conventional features. These could be the deep features. In fact, we use a lot of deep learning models to induce those features or learn those features through deep networks. Semi-supervision in the form of unlabeled data, and a generative model which actually is trained to put these together. So in addition, we have this very important thing which Professor Varsha talked about, is subset selection. So the generative model is a simple aggregation where you're looking at the behavior of these labeling functions on the examples, that is Lij. Li is a labeling function, J is an example, trying to maximize the likelihood with respect to the labels that you want to infer. Now these labeling functions, as I said, are parameterized. So there's a simple parameterization through an exponential model. And the approach is look at how the features, phi stands for the features, how the features, let's say through a deep learning, through a deep neural network, how these features minimize the error or the cross entropy in this case on the labeled set. As I said, this is optional. You may only have one labeled set, in which case you're looking at minimizing the entropy based on those features on the unlabeled set. But in addition, as I said, you have the parameters theta, which are associated with the labeling functions. That's where you can actually bring to fore the strength of the unlabeled set, potentially in conjunction with the labeled set through the parameters theta, and that's where the likelihood function I brought up earlier plays a role. And what would you do? You would actually look at how well the distribution induced based on the labeling functions through the theta, the posterior on the labels, how well it matches the posterior based on the features. As I said, these features could come through a conventional deep neural network. Now this matching of these distributions is what makes us possible to potentially even avoid use of the label set, because you could just do this matching based on the unlabeled set. So just to put the story together, this is what gives us semi-supervised data programming. You have a feature model in red, you have the semi-supervision, and what you're able to do is look at loss functions which compare the feature model predictions with the labeling function predictions, in addition to a bunch of objectives which also look at how well the likelihood using the labeling functions through the parameters theta is maximized on the unlabeled set or the labeled set if that's also available. Now to add, and this is the kind of graphical model which actually helps aggregate the signals from the labeling functions. In addition, question could be, what if I had no idea what the label set should be? That's very interesting. So the label set itself could be obtained as part of an intelligent query. We want a set of label sets which actually complement the rules, and this is in practice very ubiquitous, right? I can write a bunch of rules for some classification task, but what I can't cover through the rules is what labeling effort achieves. But what should be the set of examples that are labeled that will complement the human written rules? So that's where we bring a lot of subset selection work. We have a library called submodlib. I won't get into that, but you could think of the labeling functions that you are providing as a bunch of queries. And I want, let's say this is a bunch of images. From these images, I want a subset of images that don't reveal person information. And you can see these two cars, which are in very different orientations and different colors, are a good subset which possibly represent a set of cars because they have different colors and different orientations, and which don't reveal information about people. Now imagine replacing this person query with the labeling functions. So that's how the subset that you obtain could be complementing the labeling functions rather than being redundant. This is where human annotation could actually be optimized. Right? There's a lot of work around this which I'll skip. So a whole bunch of algorithms were implemented and available as part of this semi-supervised data programming package. Now coming back to the ingredients, right? This was, I was talking about the second and third ingredients, which was about human in the loop learning, learning through edits, learning through simple signal processing rules. That's what Spear enables. What we did in the Udaan ecosystem is put together all of this, an end-to-end ecosystem. And as I said, we were able to, by virtue of integrating layout parsing, dictionary constraints, human in the loop, we were able to show 6 to 10 factor speed up over conventional approaches. This won a best demonstration award. This is how it pans out to be. Right? You can actually edit the text in the center and have these rules induce and make global edits based on the consistency across the context. And interestingly, if you look at this, there's also a time log. You can actually profile the amount of time that is required to edit pages, and we typically find that this curve goes down because the model is learning very quickly. So these are the stages of our workflow. You upload the document, you actually get the entire layout parsing done, you ingest the dictionary translation comes out, and thankfully because of this, the usage of this has been phenomenal. We have got thousands of books translated so far over a period of around 1.5 to 2 years. This also has been reflected in Bhashini, which is the mighty program for machine translation, OCR and all of that. Thankfully also because of this effort, we got a whole bunch of dictionaries digitized. In fact, we have also programs to generate new dictionary terms in Indian languages for conventional English terms. So we work closely with the Commission for Scientific and technical terminology in not only digitizing but also coming up with new technical terms using some of these important concepts I talked about across multiple fields. This is just to give you an idea. Besides all of this, also work has got technology license. I'm very grateful to Mr. Arnal, who believed in this Udaan work almost 10 years back, and now the work is actually also commercialized. So besides being open source, there's someone who can actually take the solution to the market, because we can't be running an industry here. So also been acknowledged by the Honorable Education Minister. AICT has acknowledged its usage across all the books that have been used, that have leveraged this machine translation tool. This is again a summary of this, and there's also an important Udaan Prashikshan initiative through our CSR, which is about improving learning outcomes in regional languages, and largely the Bihar area is where it got adopted. But yeah, this is just a summary of its adoption. Now coming to usage at home, we have been also using this system to generate a lot of data for our Bharat Gen project, which has been funded by the Department of Science and Technology. This is helping us generate a lot of corpus in Indian languages through this domain-constrained, explainable, provenance-based machine translation. So these are the stages of the pipeline, and thank you very much.